Hi, my name is Klosowiak, and my instrument which I built is an accelerometer, and it consists of two circuit boards, an accelerometer and a data logger which collects the data. And the way it works is that there's an SD card, micro SD card, which is placed inside the data logger, and it collects the data. Now what we do is we turn the accelerometer on, it starts collecting data, and what an accelerometer does is it detects how fast something is speeding up or slowing down. So when I go like this, it speeds up and slows down. We then turn the accelerometer off, and we can record the data and put the data in the computer. Now if you look at here, on my computer, we have a simple graph of what the acceleration looked like. So here the acceleration goes up, and then here it's slowing down, so therefore it's negative. Here it's at 0. And so what we do is we take the accelerometer, we put it in a little Ziploc bag, and we simply tape this instrument onto the sea perch. Once it's taped on the sea perch, we put it in the water, and we collect the data. So some of the principles we will be using with this accelerometer are soldering. We'll have to solder the wires from the accelerometer, the capacitive accelerometer, to the data logger. We'll also learn how to acquire data and how to calibrate that data so that it becomes useful, so that we can see the acceleration in actual meters per second squared and convert that into force. Now the first thing we need to do is make sure that the data logger is set up properly. We do this by opening the micro SD card file. We find the logcon file, open that, and here we see that we change the mode to 2, we change the frequency to 100, and we change the first port, which is labeled as AD0.3, to Y, keeping all the other ones at N, which means off. Now, once we have the data logger set up, we take data, putting the micro SD card into the data logger, pressing the on switch, and we will know that it is collecting data by the alternating LEDs right here on this side. Once we have gathered data, imagine we gather data for a motion such as this. It accelerates and then slows down. Speeds up, slows down, back to 0. We can see here in the graph, this is a plot of that data. We see here positive acceleration and here negative acceleration. This represents the speeding up of the object. This represents the slowing down of the object. And now we have one problem. Here the acceleration is in millivolts. This is the raw data taken straight from the accelerometer. Now what we have to do is calibrate the data. We calibrate the data by gathering information again, recording the data, and we record the data by pressing the on switch. It starts recording, and we see here this line right here represents the horizontal. It's in this position. Then while it's still recording, we place the accelerometer in this position, which X direction is pointing down, gives us a negative 9.8 meters per second squared. Then we place the accelerometer in this orientation, giving a positive 9.8 meters per second squared, and then back into the horizontal orientation, which gives us 0 acceleration. Now with this calibrated data, with this calibration data, we can calibrate the original data by making a trend line. Here we have millivolts on the x-axis and the acceleration due to gravity. Here it's negative 9.8, 0, and positive 9.8. We calculate the trend line, which is the line of best fit, and we use this equation to calibrate our original data. After that process, we have our final graph, which represents the real acceleration. For example, if we want to take the maximum acceleration of this object, we go here to the maximum, we see it's about 1.5 meters per second squared. Now if we want to find the force, we take that number, multiply by mass, and we then get the force. The materials we'll be needing for the assembly of the accelerometer are this capacitive accelerometer circuit board, the data logger circuit board, which comes with a battery and a micro SD card, and we'll be also needing 4 wires, preferably of different colors. We'll also be needing a soldering iron and some wire cutters. And those are the materials and tools we will be needing for this assembly procedure. Now it is very important that we solder the right wires to the right locations. Here we have a spec of the locations. Here's the accelerometer and the ports on the accelerometer. Here we have the ports on the data logger and the corresponding locations. Now it's also important that when we solder the wires, we make sure that there's room to press the on and off switch and also the stop button, so that when it is in the Ziploc bag, it is accessible.